Hi, this is a video just kind of getting into a little bit more depth on electron configuration and also orbital notation. So first thing when we do this problem together is if I want to write the complete electron configuration for cobalt, so not the noble gas, but 3s2, 3p6, 4s2, and then 3d, and then you count over 1, 2, 3, 4, 5, 6, 7. So then you can also write an orbital notation for cobalt, and we're just going to write them left to right. So the line represents the orbital, so this would be 1s2, those each arrow is an electron, 2s2. And then when I do the 2p, I want to draw 3 orbitals. Hund's rule right there. Pauli exclusion. 2p6. 3s2. Then I want to draw those 3 together again. 3p6. And then 4s2. And then the d's, I'm going to draw 5 orbitals because there's 5 orbitals in a d sublevel. So I would do Hund's rule, 3, 4, and then I would double, 6, 7. So when you do this orbital drawing, you can see a little more detail, like there's 3 unpaired electrons there. Some other types of questions that we might ask you are how many outer shell electrons, which are also known as valence electrons. When you do that, you want to find the largest n value, which is n equals 4 here. So these 2 electrons are on the outermost part of the atom. So they are valence electrons. So how many outer? There's going to be 2. And then the inner shell is going to be all the other electrons, so all of these plus these. So you can just calculate it by taking, the atomic number of cobalt was 27 total electrons, and then if we subtract those 2 outer shell electrons, we're left with 25 then. Inner shell, also known as core electrons. How many full orbitals? This is helpful again to use the orbital drawing for this, but we can see there's 1 full orbital there. Here's another, so that's 2, 3, 4, 5, 6, 7, 8, 9 orbitals, 10, and then 11 and 12. So we have 12 full orbitals. And then they're asking me for the total number of d orbitals. There are, just right here, 1, 2, 3, 4, 5. So if it had been a bigger element, like let's say the element underneath it, it would have been, I'll do the noble gas for RH. It would equal krypton, and then 5s2, 5s2, 40, 1, 2, 3, 4, 5, 6, 7, 47. So if I had asked you the d orbitals here, you would have said that there's 5 orbitals in the 4d, but in this krypton, there's also a 3d. So this would have a total of 5 orbitals there and 5 here for a total of 10.